For thousands of years, they have stood silent against the desert sky, monuments of such staggering scale and precision that they defy simple explanation. The Great Pyramid of Giza, the last surviving wonder of the ancient world, rises from the sands with a quiet, imposing majesty that continues to captivate and mystify. We gaze upon these structures with a sense of awe, yet how much do we truly understand about the hands that built them, the minds that conceived them, or the civilization that achieved what seems, even by today's standards, nearly impossible? Despite centuries of exploration, research, and speculation, the ancient pyramids guard their deepest truths closely. We've measured their dimensions, mapped their chambers, and studied their alignments, yet with every answer uncovered, new and more profound questions emerge. How were blocks weighing multiple tons lifted and positioned with near-perfect accuracy? What hidden passages or chambers might still lie undiscovered beneath the stone? Why do these monuments reflect such advanced astronomical knowledge, and what purpose did they truly serve beyond being tombs for pharaohs? This video invites you on a journey into the heart of one of history's most compelling mysteries. Together, we'll uncover 25 unsolved enigmas surrounding the pyramids, questions that archaeologists, engineers, and historians are still wrestling with today. From the tools and techniques used in their construction to the symbolic and spiritual meanings encoded in their design, we'll explore how these ancient wonders continue to challenge everything we think we know about human capability, ingenuity, and the drive to create something eternal. So settle in, open your mind, and prepare to see the pyramids not as static relics of the past, but as living puzzles waiting to be solved. But to truly grasp the first mystery, we must move beyond the pyramid's massive scale and confront a detail of almost impossible refinement. The Great Pyramid is aligned to the geographic North Pole with an accuracy that borders on the supernatural. Its 4 base sides are oriented to the 4 cardinal directions with an average error of just 3/60ths of a single degree. To put that into perspective, the 19th century Royal Observatory in Greenwich, built with the most advanced instruments of its time, has a misalignment 10 times greater. This isn't just clothes, it is a feat of precision engineering that seems to defy the technological context of its time. How could a civilization without magnetic compasses, without advanced optics, achieve such a perfect orientation? The prevailing theory suggests the ancient Egyptians used an astronomical method, perhaps tracking the stars. One compelling idea is the simultaneous transit method, involving sighting on 2 stars that circle the true north celestial pole. By bisecting the angle of their rise and set points over a long night, an architect could theoretically establish a true north-south line. Another method involves using a simple gnomon, a vertical rod, and tracking the tip of its shadow throughout the day to create a perfect east-west line, which then easily gives you north and south. Yet the practical execution of these theories is fraught with challenges. The desert horizon isn't perfectly flat, atmospheric conditions can distort light, and achieving an error margin of just 3 arc minutes would require not just knowledge, but an almost obsessive level of patience and skill repeated perfectly across a massive construction site. This leads to an intriguing and persistent debate. Did the ancient Egyptians possess a sophisticated, and since lost, understanding of spherical astronomy and geometry that we have yet to fully appreciate? Or does this pinpoint accuracy hint at the use of a tool or technique so simple and effective that it has been overlooked by modern archaeology? The alignment is not a grand hidden chamber or a cryptic inscription. It is a silent, mathematical truth etched into the very foundation of the monument, a quiet testament to a knowledge base we are still striving to comprehend. This staggering precision with alignment is only the beginning of the puzzle. To truly appreciate the magnitude of the mystery, we must now confront the sheer physical reality of the Great Pyramid's construction. The numbers alone are enough to induce a kind of intellectual vertigo. we are looking at a structure composed of approximately 2.3 million individual limestone blocks, each weighing an average of 2.5 tons. That is the equivalent of stacking the entire fleet of the United States Navy's aircraft carriers, nearly 30 ships, into a perfect geometric mountain. And this was accomplished over an estimated 20-year period, a time frame that demands a relentless, breathtaking pace of work. Just consider the logistics. Every single day, workers would have had to quarry, transport, lift, and set into perfect position one block every 2 to 3 minutes of a 10-hour workday. This was not a single project but a symphony of coordinated efforts, each presenting its own seemingly insurmountable challenge. How were these colossal stones extracted from the earth? Archaeologists have found evidence of workers using simple dolerite stone hammers and copper chisels to pound channels around each block, then inserting wooden wedges that were soaked with water to expand and crack the stone free from the bedrock. It was a monumental exercise in patience and brute force. Then came the journey from the quarry to the construction site, a distance that could be hundreds of miles for the finest white Tura limestone used for the casing stones. The prevailing theory, supported by a famous wall painting in the tomb of Jehutuhotep that shows a massive statue being moved on a sledge, suggests that workers hauled these blocks on wooden sledges. But even with a sledge, moving a 2.5-ton block across sand and rock is a Herculean task. A fascinating discovery added a crucial piece to this puzzle. Experiments have shown that wetting the sand in front of the sledge dramatically reduces friction, making it possible for a team of laborers to pull the immense weight with far less effort. This simple yet brilliant technique might have been their key to transportation, but the greatest enigma of all is how these blocks were then lifted hundreds of feet into the air and placed with millimeter precision. The textbook answer is ramps. Archaeologists generally agree that some form of ramp system must have been used, but the design of that ramp is hotly debated. A single, long, straight ramp would have been too massive, requiring more material than the pyramid itself by the time it reached the upper levels. A more plausible theory involves a spiraling ramp, either built against the outside of the pyramid or corkscrewing up its interior within the structure itself. Others propose a combination of a straight ramp for the lower courses and a more complex internal spiral for the upper ones. Yet, despite extensive searching, no definitive archaeological evidence for any major ramp structure has been found at Giza. The lack of this evidence is a gaping hole in an otherwise logical theory. This void of proof has naturally given rise to more speculative ideas. Some researchers point to the incredible precision of the stone cutting and propose the ancient Egyptians might have possessed a lost form of advanced technology, perhaps even a method to soften or mold stone, making it easier to shape and fit. Others, looking at the global phenomenon of megalithic construction, have suggested the involvement of a much older, more sophisticated civilization whose knowledge was later lost. And then there are the more fringe theories that reach for extraterrestrial assistance, arguing that such a feat was simply beyond human capability 4,500 years ago. But to attribute this work to aliens is to dismiss the incredible ingenuity, organization, and sheer willpower of the ancient Egyptians. What the physical evidence does show us are the marks of trial and error, the worker settlements that housed a rotating workforce of thousands and the remnants of their tools. This was likely the achievement of a highly organized society that mobilized its entire population, leveraging a deep understanding of leverage, rollers, and simple machines. The real mystery may not be a single lost technology, but the astonishing social and managerial genius required to coordinate such an endeavor for a generation. A human accomplishment so profound that it continues to challenge our modern assumptions about the past. Yet for all the back-breaking labor and ingenious logistics, perhaps the most profound mystery lies not in how the pyramids were built, but why. The traditional explanation taught in schools for generations is straightforward. They were grand tombs designed to protect the physical body of a god-king for eternity and facilitate his journey to the afterlife. This tomb theory is supported by a compelling logic. We find pyramid complexes with mortuary temples, causeways, and smaller pyramids for queens, all elements that fit a funerary function. The discovery of King Tutankhamun's lavish tomb in the Valley of the Kings seems to cement the idea that the Egyptians invested enormous resources in burial. But when we apply this theory directly to the Great Pyramid, troubling anomalies begin to surface. The most glaring issue is the stark absence of any burial. No pharaoh's mummy, no treasure, no funerary artifacts, none of the hallmarks of a royal tomb have ever been found inside the Great Pyramid. The sarcophagus in the king's chamber is an empty, lidless box of solid granite, seemingly placed there during construction and never used. This void is not an isolated case. Of the over 100 pyramids identified in Egypt, the vast majority have been found completely empty, stripped clean by looters in antiquity, or never used in the first place. This forces a difficult question. If these were tombs, why do they so consistently lack their primary occupant? The historical timeline adds another layer of intrigue. The first true pyramid, the Step Pyramid of Djoser at Saqqara, was indeed a burial site, but the first known Egyptian mummy, that of a woman from a much later period, was not found in a pyramid at all, but in a simple, rocky tomb. This suggests that the elaborate mummification practices we associate with the pharaohs may have developed after the pyramid building era peaked. So if preserving the body wasn't the initial driving force, what was? This void in the traditional explanation has opened the door for a host of alternative theories about the pyramid's true purpose. Some researchers, like engineer Christopher Dunn, argue that the extreme precision, the complex internal channels, and the specific materials used point to a function far more sophisticated than a simple tomb. Dunn, in his book The Giza Power Plant, proposes that the Great Pyramid was a massive harmonic resonance device, a machine designed to convert the Earth's vibrational energy into microwave or electromagnetic energy. He points to the architecture, the granite in the king's chamber, which contains quartz crystals that can piezoelectricity, the precise dimensions of the so-called air shafts that might have acted as waveguides, and the large, empty grand gallery, which could have served as a sound resonance chamber. In this model, the pyramid wasn't a tomb for a dead king, but a powerful technological instrument for the living. Other theories pivot toward the astronomical. The precise alignment of the shafts within the Great Pyramid with specific stars, like Orion and Thuban, which was the pole star in 2500 BC, suggests a function as an observatory or a celestial calendar. Before the pyramid was capped, its inner passages could have been used by priests to track the movement of stars with incredible accuracy, marking the seasons and predicting the annual Nile flood, which was the lifeblood of their civilization. It could have been a gateway between the earth and the heavens, a permanent stone representation of their cosmic beliefs. There is also the spiritual or energetic perspective. Many visitors and researchers report strange sensations within the pyramid's chambers, a feeling of heightened awareness, a buzzing energy, or a profound sense of peace. While subjective, these accounts have led to speculation that the pyramid's shape and materials were designed to amplify spiritual energy or consciousness, serving as a center for initiation rites or deep meditation. The very geometry of the pyramid is said to focus energy toward its center, a concept that, while not fully understood by modern science, continues to inspire both New Age thought and serious scientific inquiry into the properties of pyramidal shapes. The truth may not be a single answer but a complex layering of all these purposes. The pyramid could have been a multi-functional masterpiece, an astronomical instrument, a spiritual center, a symbol of royal power, and yes, eventually a tomb. To force it into a single category might be to misunderstand the ancient Egyptian worldview, where science, religion, and technology were not separate fields but intertwined aspects of a unified cosmic order. The absence of a mummy, then, isn't a case of a missing body, but perhaps a clue that we have been missing the point entirely, looking for a purpose where there were, in fact, many. Even as we debate the pyramid's ultimate purpose, its physical form presents another layer of enigma, one hidden within its very walls. Beyond the well-known passages open to tourists lies a secret internal anatomy that we are only just beginning to map. The standard tour route takes you through the ascending passage, into the breathtaking Grand Gallery, and finally to the austere King's Chamber with its enigmatic granite sarcophagus. Below it, accessed by a separate descending corridor, lies the misnamed Queen's Chamber, a simpler, limestone room that likely never held a queen's burial. These spaces are astounding, but they represent only the known public face of the pyramid's internal design. The Grand Gallery itself is a masterpiece of engineering that defies simple explanation. It is a colossal corridor over 46 meters long and nearly 9 meters high, with a complex corbelled vault ceiling that has stood for millennia without collapse. Its function remains speculative. Was it a grand staging area for the massive granite blocks used to plug the passages after the king's burial? Could its unique shape have served an acoustic purpose, amplifying specific sound frequencies as part of a ritual or even a technological function? The precision of its construction suggests its role was far more critical than simply being a fancy hallway. For centuries, Egyptologists believed these few chambers were all the pyramid contained. But the structure has always whispered of more. The discovery in the 19th century of 4 narrow shafts, 2 from the King's Chamber leading outside and 2 from the Queen's Chamber that originally ended mysteriously within the masonry, fueled speculation. Why create these incredibly narrow, precisely angled tunnels? The northern shaft from the Queen's Chamber was finally explored in 2002 by a team using a miniature robot, only to find it blocked by a small limestone door with copper handles. When they drilled through it, they found another, similar door just inches behind it, a deeply puzzling and seemingly symbolic barrier. This tantalizing find was merely a prelude to a much larger discovery. Modern technology has given us new eyes to see inside the stone. Using muon tomography, a technique that utilizes cosmic rays to penetrate dense matter and reveal voids, scientists from the Scan Pyramids project made a staggering announcement in 2017. They had detected a massive, previously unknown void situated directly above the Grand Gallery. Dubbed simply the Big Void, this space is estimated to be over 30 meters long and have a cross-section similar to that of the Grand Gallery itself, suggesting it could be another grand corridor. Its purpose is a complete mystery. This is not the only hidden space. Scans have suggested other, smaller voids and anomalies throughout the pyramid's infrastructure, hinting at a complex internal latticework that we are only beginning to perceive. The immediate and most thrilling question is, what are these spaces for? The possibilities are as numerous as they are captivating. Could the Big Void be a relieving chamber designed to distribute the immense weight of the masonry away from the Grand Gallery below? While this is a functional theory, the sheer scale of the void seems excessive for that purpose alone. Perhaps these chambers are not structural but functional, containing the very artifacts or knowledge that would unlock the pyramid's secret. The romantic hope is that one of these sealed spaces could be a hidden treasury, a library, or a chamber containing the burial of the pharaoh himself, untouched by looters. The concept of a hidden burial chamber away from the expected locations is not without precedent in Egyptian architecture designed to outwit tomb robbers. Alternatively, these voids could be integral to the pyramid's proposed function as a machine or instrument. They might represent resonance chambers, architectural features designed to manipulate sound waves or energy in ways we don't yet understand. The muon scans provide a shadowy outline, a ghostly negative image of emptiness, but they cannot tell us what is inside, whether it is air, artifacts, or intricate architectural features. The existence of these sealed chambers forces us to confront another difficult question. Why were they so deliberately hidden and sealed off? If their purpose was purely structural, there would be no need to conceal their existence so completely from the internal passages. The careful sealing implies intention, perhaps to protect something sacred or powerful, or to permanently separate a functional area from the more symbolic or funerary sections of the monument. Each new scan doesn't provide an answer, it simply deepens the mystery, proving that the Great Pyramid, even after 4,500 years, still has secrets waiting in the dark. Moving from the physical voids hidden within the stone, we encounter an altogether different kind of emptiness, one filled not with air but with meaning. The Great Pyramid is not merely a collection of chambers and corridors, it is a monumental equation carved in limestone, a structure whose very dimensions whisper secrets of advanced mathematical understanding. The most famous of these numerical whispers is the tantalizing appearance of pi, the fundamental constant of a circle, found in the ratio of the pyramid's perimeter to its original height. If you take the perimeter of the base and divide it by twice the original height, you get a figure astonishingly close to 3.1415, the value of pi. This is not a rough approximation, it is a precision that seems to defy coincidence, suggesting the architects were not just builders but master geometers. This mathematical fingerprint extends far beyond pi. The pyramid's base perimeter, when measured in the ancient Egyptian unit known as the cubit, is exactly 365.24, a number that mirrors the number of days in a solar year. Its height, multiplied by 43,200, a significant number in ancient astronomy related to the precession of the equinoxes, gives you a figure remarkably close to the polar radius of the Earth. Furthermore, the structure's location itself is a mathematical statement. It sits at the intersection of the longest line of longitude and the longest line of latitude, a point that could be considered the center of the Earth's landmass. The cumulative weight of these correlations is staggering. It pushes beyond the realm of chance and into the territory of intentional design, pointing toward a civilization with a sophisticated grasp of spherical Earth concepts and astronomical cycles that we typically do not attribute to them. This leads to a fierce and ongoing debate. Are we witnessing intentional genius or a classic case of apophenia, the human tendency to find meaningful patterns in random data? The skeptical viewpoint, held by many mainstream Egyptologists, argues that these mathematical marvels are largely coincidental. They point out that the ancient Egyptians, while brilliant practical mathematicians, never demonstrated a theoretical understanding of pi in any of their surviving papyri. Their system of mathematics was additive and based on unit fractions, not the abstract geometry required to conceptualize an irrational number like pi. The correlation to the Earth's dimensions, they argue, is a happy accident of the unit of measurement they chose, the cubit. If you use any standard unit of measure on a structure this large, they contend, you can inevitably find some correspondence to some natural constant if you look hard enough. Yet the counterargument is profoundly compelling. Proponents of intentional design ask us to consider the sheer number of precise correlations. One or two could be dismissed as coincidence, but a whole suite of them, all integrated into a single structure, suggests a blueprint of incredible depth. They propose that this knowledge may have been the purview of a highly secretive priestly class, an oral tradition of sacred geometry that was never written down in the administrative texts that have survived. The pyramid, in this view, was not just a tomb or a temple, but a stone library, a permanent repository of this advanced knowledge encoded in its proportions for future generations, or perhaps for the gods themselves. It stands as a silent challenge to our linear view of human progress, forcing us to wonder if a golden age of knowledge rose and fell long before recorded history began, leaving only these immense cryptic monuments as its only testament. But if the pyramid's design suggests a knowledge that seems out of place, its proposed age might be just as anachronistic. The conventional timeline established by archaeologists places the construction of the Giza complex firmly in the 4th dynasty of Egypt's Old Kingdom, around 2500 BC. This dating is based on a combination of evidence, the style of the monuments, the nearby worker villages, and a handful of inscriptions linking Khufu to the site. It is a chronology that is taught in textbooks and presented in museums as established fact. Yet, a growing body of evidence from the Giza Plateau itself is challenging this timeline in ways that are impossible to ignore, suggesting these structures might be far, far older. The most compelling challenge comes not from the pyramids, but from their silent guardian, the Great Sphinx. Egyptology maintains that the Sphinx was carved during the reign of Khufu's son, Pharaoh Khafre, around 2500 BC. However, in the early 1990s, a controversial but deeply insightful geologist named Dr. Robert Schoch brought a new set of eyes to the monument. Schoch wasn't an Egyptologist, he was a scientist who specialized in rock erosion patterns. What he observed on the body of the Sphinx and the walls of its enclosure trench sent shockwaves through the field. The erosion on the Sphinx, he argued, is not primarily from wind and sand, which would wear away at the stone horizontally. Instead, the deep, vertical, and undulating fissures that cover its body are classic textbook examples of water erosion, specifically from heavy, sustained rainfall. This type of weathering requires a climate drastically different from the hyper-arid conditions that have dominated the Giza Plateau for the last 5,000 years. To create such deep, runneled channels, the area would have needed to experience significant and regular precipitation, a climate that Egypt has not seen since the end of the last ice age over 10,000 years ago. Schoch's analysis, supported by other geologists, points to a minimum age for the core body of the Sphinx of 7,000 to 10,000 years, a dating that would completely upend our understanding of human civilization. This geological evidence found a powerful partner in the stars through the work of author Robert Bovell. In his Orion correlation theory, Bovell proposed that the layout of the 3 main Giza pyramids mirrors the alignment of the 3 stars in Orion's belt. This in itself is not entirely controversial. The Egyptians deeply associated Osiris, the god of the afterlife, with the Orion constellation. However, Bovell took it a step further. He noted that due to the slow wobble of the Earth's axis, a cycle known as precession, the stars gradually changed their position in the night sky over a 26,000-year period. While the pyramid's ground layout matches Orion's belt, the relative brightness of the stars as represented by the size of the pyramids, and even the course of the Nile mirroring the Milky Way, the alignment is not perfect for 2500 BC. Bovell's crucial insight was that the correlation is mathematically perfect for one specific date, 10,450 BC. At that remote time, the constellation of Orion would have been at its lowest point in its precessional cycle, precisely matching the pattern on the ground. This suggests the Giza complex could have been planned, or at least begun, in a vastly more ancient epoch, a time when the Sahara was a verdant grassland and humanity was supposedly in the Paleolithic age, just emerging from hunter-gatherer societies. These theories, championed by figures like Schoch, Bovell, and the late John Anthony West, were met with fierce resistance from the Egyptological establishment. The criticism was multifaceted and often intense. Mainstream scholars argued that the water erosion on the Sphinx could be explained by wind, sand, the effects of exfoliation, or even runoff from dew condensation. They dismissed the Orion correlation as selective pattern matching, arguing that if you look at enough stars and enough monuments, you can force a correlation to almost any date you choose. They pointed to the utter lack of any archaeological evidence, no tools, no settlements, no pottery for advanced civilization in Egypt during the 10th millennium BC. The debate quickly became polarized, often framed as a battle between rigid, close-minded academics and reckless, sensationalist outsiders. But to dismiss it so simply is to miss the profound questions at its heart. The geological evidence on the Sphinx enclosure remains a visible, tangible anomaly that the standard wind-sand erosion model has never fully satisfactorily explained for many observers. The astronomical correlation, while speculative, is a sophisticated mathematical proposition that cannot be easily waved away. Perhaps the truth lies not in a binary choice but in a more complex narrative. Maybe the Sphinx is indeed a much older monument, a pre-existing megalith that was later recarved and adopted by Pharaoh Khafre, who then built his pyramid next to it. This would explain the water erosion on the body while accommodating the archaeological evidence linking Khafre to the site. Similarly, the astronomical knowledge encoded at Giza could represent a legacy, a sacred geometry passed down from a much older, perhaps now vanished culture that first recognized these celestial cycles. This would mean the pyramids are not the beginning of a civilization, but the magnificent culmination of a far older one, a peak built upon foundations we have yet to discover. This theory doesn't just change a date, it shatters the conventional timeline of human history, suggesting that the story of civilization is far older and far more mysterious than we have ever dared to believe. Yet even if we accept a far older origin for the plateau's master plan, the physical act of construction presents its own separate set of mysteries locked within the very stone itself. To walk among the pyramid's core blocks is to witness a kind of rustic majesty, massive, rough-hewn limestone chunks fitted together with gaps you can sometimes fit your hand into. But then you encounter the interior chambers, and the precision shifts into an entirely different dimension. Here, in the king's chamber, we are faced with a puzzle of hardness and precision that seems to defy the official historical record. The chamber is constructed from immense blocks of red granite, a material so notoriously tough that it ranks just below diamond on the Mohs scale of hardness. Working this stone with the tools Egyptologists attribute to the builder's copper chisels and dolerite hammers would be like trying to carve a detailed statue using a piece of soft cheese. Copper is a malleable metal. Striking it against granite would simply blunt and deform the tool long before it made significant progress on the stone. The evidence of this advanced workmanship is everywhere you look. The granite sarcophagus in the king's chamber is perhaps the most famous example. It is carved from a single, massive block of granite with an interior hollowed out. The corners are perfectly square, the surfaces incredibly smooth, and the tolerances between the sides and bottom are so tight that it's often said a credit card cannot be slid between them. Even more telling are the drill cores found in Egypt, such as the one from the temple at Abusir. This core, extracted from a hole drilled into a block of granite, shows spiral grooves that are perfectly uniform and incredibly deep. The spacing of these grooves indicates a drill that was not only harder than granite, but also fed into the stone with a consistent, tremendous pressure, a feat that seems impossible for a handheld bow drill using a copper or even a dolerite bit. This disparity between the tools we know they had and the work we know they did has led to a fascinating schism in thought. The mainstream archaeological view holds that the ancient Egyptians achieved all of this with simple tools, immense patience, and abrasive powders. The theory goes that they used copper saws and drills, but instead of the metal itself doing the cutting, they employed a slurry of water and a harder abrasive material like quartz sand. By constantly rubbing this abrasive mixture back and forth with a copper blade or drill tube, they could slowly, ever so slowly, grind their way through the granite. It is a method that is technically plausible, but when you scale it up to the volume of work in the pyramid's granite chambers, the time and labor required become almost unimaginable. To hollow out the granite sarcophagus using this method would have been a project lasting years, demanding an inhuman level of consistent effort. For many engineers and machinists who examine this work, the abrasive theory feels insufficient. They point to the uncanny precision of the cuts, the perfectly flat surfaces, the right-angled corners, the consistent drill grooves, and argue that this is evidence of machine-grade tooling. Some propose that the Egyptians must have possessed and then lost a technology for creating hardened metal tools, perhaps an early form of steel, that has simply not survived in the archaeological record. Others look at the precise, concentric grooves in the granite drill cores and suggest the use of a fixed mechanical drill that applied tons of pressure, a device far more advanced than a simple handheld tool. This void in the conventional explanation has given rise to more speculative, yet intriguingly coherent alternative theories. One compelling idea involves the use of sound waves or vibrational technology. Experiments have shown that certain frequencies of sound can cause materials to resonate, effectively liquefying them or making them easier to manipulate. Could the builders have used tuned instruments to vibrate the granite, allowing them to shape it with less force? This might explain the legendary account that the stones for the pyramids were levitated into place, not by anti-gravity, but by using resonant frequencies to dramatically reduce friction and weight, making the multi-ton blocks easier to move. Another lost technology theory involves the use of chemical agents to soften stone. There are ancient accounts, including from the historian Herodotus, who was told by Egyptian priests that the stones were quarried by using a mysterious liquid that was poured onto the stone to make it easy to cut. While this sounds like fantasy, modern experiments have shown that certain organic acids, like those found in citrus fruits or even the mineral natron, can indeed affect the surface chemistry of some stones, potentially making them softer and easier to work for a limited time. Perhaps the Egyptians discovered a natural geopolymer or a chemical process that allowed them to mold or cast stone blocks on site, which would explain the seemingly impossible fits between massive blocks without any mortar. The evidence for this is not just in legend. There are stones in ancient Egyptian quarries that appear to have been partially melted or softened, with tool marks that look more like scooping than chiseling. The question of their tools is not a trivial one. It strikes at the very heart of how we view ancient technological progress. Were the pyramid builders merely incredibly patient and organized Neolithic craftsmen, grinding away for generations with simple tools? Or does the evidence locked in the granite suggest a higher level of technological sophistication, a peak of knowledge that was reached and then lost, leaving behind only these magnificent, enigmatic monuments as proof of its existence? The stones themselves do not say, but their perfect, silent surfaces continue to challenge our most fundamental assumptions about the past. This architectural echo across the globe presents one of the most tantalizing mysteries. Why do so many ancient cultures, separated by vast oceans and thousands of years, all build pyramids? The Great Pyramid of Giza is not an isolated phenomenon but part of a global pattern, a recurring architectural dream that appears to have captured the human imagination in every corner of the ancient world. From the dense jungles of Guatemala to the plains of northern China, and even in the hills of Bosnia, these structures rise from the earth with a familiar, imposing geometry. In Mesoamerica, the Maya and Aztec civilizations constructed stepped pyramids like the magnificent temple of Kukulkan at Chichen Itza. While its shape is more pronouncedly tiered than the smooth-sided Egyptian pyramids, the underlying purpose reveals striking parallels. It was a profoundly sacred space, an astronomical observatory, and a spiritual gateway. Its design is precisely aligned with the solar cycles. During the spring and autumn equinoxes, the interplay of sunlight and shadow creates the illusion of a serpent slithering down the staircase, connecting the earth to the heavens in a dramatic display of light and architecture. This obsession with celestial alignment is a direct mirror of the Great Pyramid's own precise orientation. Even more astonishing are the pyramids of China, long hidden under earthen mounds that disguised their true shape for centuries. Near the city of Xi'an, over 100 pyramids dot the landscape, with the White Pyramid being one of the most famous. These structures, primarily built as tombs for early emperors during the Han and Tang dynasties, share the same four-sided pyramidal base. While their construction of rammed earth and brick differs from stone, Their alignment to cardinal directions and their function as sacred burial sites create an undeniable resonance with the Egyptian tradition. The debate around these similarities ignites a fundamental question about human history. Are we looking at evidence of a shared, now lost source of knowledge, a single, advanced progenitor civilization that spanned the globe in a forgotten age, seeding these ideas across different cultures? This diffusionist theory suggests that ancient mariners or a much older global network could have facilitated the spread of architectural and astronomical concepts. Alternatively, could the pyramid shape be an example of independent invention or psychic unity, a form so inherently stable, symbolically powerful, and logically sound that different cultures arrived at it independently while solving similar problems of building tall, lasting monuments to their gods and rulers? The possibility of a shared ancient knowledge is fueled by more than just shape. The pervasive emphasis on celestial alignment, the use of precise mathematics, and the role of these structures as centers of both spiritual and scientific learning suggest a common understanding of the universe that transcends culture. The pyramid, in its perfect stability and upward reach, seems to be the ultimate natural symbol for humanity's attempt to bridge the earthly and the divine, a concept that could have arisen spontaneously in any advanced society. This global pattern forces us to reconsider the narrative of isolated civilizations and wonder if the ancient world was far more interconnected, or perhaps inspired by a common, much older source than our history books have ever acknowledged. Beyond the debates of history and archaeology lies a mystery that is both deeply personal and strikingly modern: the persistent claim that the pyramid shape itself holds unique and tangible energy properties. This idea pushes beyond the realm of symbolism and into the physical world, suggesting that the geometry of the Great Pyramid can directly influence its surroundings in measurable and sometimes bizarre ways. The most famous and enduring anecdote comes from mid-20th century France, where a hardware merchant named Antoine Bovis claimed that after visiting the king's chamber, he noticed small animals that had died inside the pyramid were not decomposing but had instead mummified naturally. Intrigued, he returned home and built small-scale wooden models of the pyramid, aligning them to true north. He allegedly placed a dead cat inside and found it also desiccated rather than rotted. This story, though anecdotal, sparked a wave of popular interest in what became known as the pyramid power phenomenon. The most widespread modern experiment involves placing a used, dull razor blade inside a scale model of a pyramid oriented to north. Enthusiasts claim that instead of becoming duller, the blade somehow realigns its microscopic edge and becomes sharp again, allowing for many more shaves. Thousands of people have reported success with this, turning their homes into miniature laboratories, but the claims extend far beyond sharpening blades. Proponents assert that pyramids can preserve organic matter like fruits and vegetables, keeping them fresh for far longer than normal. They say water left inside a pyramid model tastes sweeter or energized, that plants grow faster when placed near one, and that meditating inside a pyramid structure can lead to heightened states of consciousness, reduced stress, and improved mental clarity. If true, these effects would suggest the pyramid is not a passive monument but an active instrument, a shape that somehow interacts with the fundamental energies of the Earth and cosmos. The question for science is whether these effects are real and reproducible, or simply the product of wishful thinking and the powerful placebo effect. A number of researchers have taken these claims into the laboratory. One of the most cited figures is Dr. Volodymyr Krasnoholovets, a Ukrainian physicist who conducted a series of experiments under the former Soviet Union. He reportedly built a series of large pyramid models across Russia and Ukraine and observed a range of strange effects. His claims were extraordinary. Seeds placed in the pyramids showed a 30 to 100% increase in yield. The immune systems of mice became stronger. the ozone hole above the pyramids allegedly decreased, and even the viscosity of oil seemed to change, making it flow more easily. Perhaps most startlingly, he suggested that the pyramids generated an energy column, or a beam of unknown energy shooting directly upward from the apex, which he believed could potentially influence weather patterns. However, the scientific community at large remains deeply skeptical, often classifying this field as pseudoscience. The primary criticism is a lack of rigorous, repeatable experimental data under controlled conditions. Many of the most sensational claims, including Krasno-Holovitz, were not published in reputable, peer-reviewed scientific journals, making it difficult for other researchers to verify the methodologies or results. Critics argue that perceived effects like food preservation or blade sharpening can be explained by well-understood natural phenomena. A pyramid model, like any sheltered structure, creates a specific microclimate inside. The shape likely influences air circulation, humidity, and temperature in a way that could slow decomposition, a principle no different from a food cellar or a drying shed. The idea of a blade being sharpened defies metallurgy. It's possible that controlled, dry air inside the model simply prevents oxidation and corrosion, making the existing edge last longer, which a user might misinterpret as resharpening. The search for a mechanism behind these alleged effects often leads to theories about focused electromagnetic energy or scalar waves. Some researchers propose that the pyramid's shape acts as a resonant cavity, collecting and concentrating the Earth's natural subtle energies or even cosmic microwave background radiation. The precise angles and materials might create a standing wave of energy within the structure. This could theoretically explain effects on organic matter at a cellular level or influence the hydrogen bonding in water, altering its properties. While mainstream science has not confirmed the existence of such energies in this form, the concept draws parallels with known physics, like how the shape of a musical instrument focuses sound waves. The real mystery may not be if the effects are real, but whether we lack the scientific instruments subtle enough to measure the type of energy involved. The pyramid shape might be interacting with aspects of reality that contemporary physics is only beginning to explore, leaving us with intriguing anecdotes waiting for a scientific framework to truly put them to the test. The identity of the master builders behind the pyramids stands as one of the most contentious and fascinating mysteries of all. Mainstream Egyptology presents a clear and established narrative. The Great Pyramid was built for the 4th dynasty pharaoh Khufu, or Cheops, around 2500 BC as his grand eternal tomb. This attribution rests on a few key pieces of evidence. Within the pyramid's relieving chambers, discovered in the 19th century, were workmen's graffiti that included Khufu's name, or more precisely, his cartouche. For traditional scholars, this is the ultimate smoking gun, the builder proudly signing his work. Furthermore, the nearby workers' village at Giza, with its bakeries, infirmaries, and tombs containing the skeletons of laborers with signs of physical stress, paints a picture of a state-sponsored, pharaonic project on an unimaginable scale. This view casts the pharaoh as the ultimate CEO, a divine ruler who commanded the resources and manpower of a unified kingdom to create a monument to his own glory and afterlife. Yet, a closer examination reveals that this attribution is not as ironclad as it first appears. The crucial Khufu cartouche found in the relieving chambers is often presented as definitive proof, but its context is deeply problematic. The graffiti was not carved in a public, dedicatory inscription, but was crudely scrawled in red ochre paint in a space that was sealed and invisible upon the pyramid's completion. This has led some researchers to question its authenticity. Could it have been a later addition, or perhaps the work of a restoration crew from Khufu's era who were repairing or modifying a much older structure? The evidence from the workers' village, while proving a large workforce was present at Giza, does not conclusively prove they were building the pyramids from scratch. They could have been engaged in renovation, restoration, or even the daunting task of adding the pristine white Chora limestone casing stones to a pre-existing core. This opens the door to a radical alternative theory that the core structure of the Great Pyramid and perhaps the Sphinx is vastly older, a relic of a pre-pharaonic civilization that was later adopted and claimed by the dynastic Egyptians. This older civilization theory is not a modern fringe idea but finds echoes in the writings of the ancient Egyptians themselves. The famed inventory stela discovered at Giza in the 19th century, though likely dating to a much later period, records that Khufu ordered the building of a monument alongside the Great Sphinx, which it describes as already being ancient in his time. While most Egyptologists dismiss the stela as a pious forgery by later priests to aggrandize the site, its very existence shows that even ancient cultures believed their own history stretched back into a much more distant and legendary past. Proponents of this view point to the geological evidence of water erosion on the Sphinx enclosure, which suggests a date of construction thousands of years before Khufu's reign, when the climate of Egypt was far wetter. They also highlight the sheer mathematical and astronomical sophistication encoded in the pyramid's dimensions, knowledge of the Earth's size, the precession of the equinoxes, and the value of pi, which seems to belong to a more advanced scientific tradition than that displayed in later Egyptian architecture. This suggests the pyramid might be the work of a lost civilization, often referred to in esoteric traditions as Atlantis or another advanced culture that flourished at the end of the last ice age, which possessed a high technology that was later almost entirely lost. In this scenario, the pharaohs of the Fourth Dynasty were not the original architects, but the inheritors and custodians of a sacred, pre-existing wonder, which they then incorporated into their own funerary cult. The most controversial theory of all pushes this idea of advanced knowledge to its extreme, venturing into the realm of extraterrestrial input. Popularized by authors like Erich von Däniken, this perspective argues that the technological leap required to build the pyramids was too great for early human civilization. The precision of the stone cutting, the alignment with true north, and the handling of multi-ton granite blocks are presented as evidence of a technology that did not exist on Earth at the time. Proponents suggest that ancient astronauts or advanced beings from another world provided the knowledge, the tools, or even the direct assistance to build these structures, perhaps as beacons, energy plants, or landing sites. They often point to ancient myths from cultures worldwide that speak of gods or sky people coming down to teach humanity the arts of civilization. Unsurprisingly, these alternative theories are met with fierce resistance from the mainstream academic community. Egyptologists argue that the evidence for Khufu's involvement, while circumstantial, is consistent with other archaeological findings and the known development of Egyptian royal tomb construction, which evolved from simple mastabas to the step pyramid and then to the true pyramids. They contend that the older civilization and ancient astronaut theories are not only unnecessary, but are also dismissive of the incredible ingenuity and capability of ancient humans. They see these ideas as a form of intellectual colonialism that denies non-Western cultures their own achievements, attributing their greatest works to outside, often white or non-human, forces rather than recognizing the indigenous genius of the Egyptian people themselves. This clash is more than an academic debate. It is a fundamental disagreement over how we view human history and potential. Is history a linear progression from primitive to advanced, or is it cyclical, with ages of brilliance rising and falling into obscurity? The mystery of the builder's identity forces us to confront uncomfortable questions about the reliability of our historical timelines and the origins of knowledge. Whether the work of a supremely organized Bronze Age society, a forgotten advanced culture from a lost age, or something even more extraordinary, the pyramids stand as a permanent challenge, refusing to neatly fit into any one narrative and compelling us to keep searching for the truth about the hands that shaped them. Beyond the physical and astronomical enigmas, the pyramid's form itself is a language, a silent sermon carved in stone speaking of a world where mathematics, spirituality, and the cosmos were inextricably linked. The shape is far more than a stable architectural choice. It is a potent symbol, its sloping sides representing the rays of the sun descending to earth, a literal ladder for the soul of the pharaoh to ascend and join the eternal gods. This connection to the sun god Ra was paramount, transforming the pyramid from a mere tomb into a machine for resurrection, a beacon designed to capture and channel divine energy to facilitate the king's rebirth. But the symbolic depth goes even deeper, encoded within the structure's very proportions through the language of sacred geometry. One of the most discussed and debated mathematical relationships found in the Great Pyramid is its potential connection to the golden ratio, often denoted by the Greek letter phi, approximately 1.618. This irrational number appears throughout nature, from the spiral of a nautilus shell to the arrangement of seeds in a sunflower, and it has been celebrated for millennia as a key to aesthetic beauty and harmonic proportion. Some researchers point out that the ratio of the pyramid's apothem, the length from the base's center to the apex, to half the length of its base is very close to phi. If you take the surface area of each of the four faces and divide it by the area of the base, the result is also strikingly close to the golden ratio. These correlations suggest the architects may have intentionally designed the pyramid to embody this divine proportion, embedding a fundamental law of the natural world into their most ambitious project. Intimately related to the golden ratio is the Fibonacci sequence, a series of numbers where each number is the sum of the two preceding ones, 0, 1, 1, 2, 3, 5, 8, 13, and so on. As the sequence progresses, the ratio between successive numbers gets closer and closer to phi. While the Egyptians would not have called it the Fibonacci sequence, they may have understood the mathematical principle behind it. The prevalence of these ratios in the pyramid's design implies a sophisticated understanding of a mathematical order that governs growth and form in the universe, from the microscopic to the galactic. By building this principle into the pyramid, they were not just constructing a tomb, they were creating a microcosm, a model of the ordered universe itself, a place where the pharaoh's soul could align with the very rhythms of creation. This drive to mirror the cosmos in architecture extends to the pyramid's interior chambers, which are believed by many to represent different stages of the soul's journey. The descending passage leading down into the bedrock could symbolize the soul's descent into the underworld, the realm of Osiris. The ascending passage, pointing directly toward the circumpolar stars that never set, stars the Egyptians associated with eternal life, then represents the soul's triumphant rise to the imperishable heavens. The Grand Gallery, with its soaring, corbelled ceiling, might be seen as the final chamber of transformation and awakening, a place of culmination before the soul enters the king's chamber, the final destination representing the highest state of spiritual enlightenment and eternal union with the divine. Ultimately, the pyramid can be interpreted as a massive three-dimensional mandala or a yantra, a geometric diagram for spiritual practice. Its precise angles and ratios were not just for structural integrity, they were a means of concentrating spiritual energy and intention. The shape itself is believed to focus energy toward its center and apex, creating a vortex of power that could facilitate meditation, healing, or communion with higher states of consciousness. This idea, while often relegated to the realm of metaphysics, finds a curious echo in the modern pyramid power experiments, suggesting that the form may indeed interact with its environment in ways we are only beginning to perceive. Whether viewed as a mathematical treatise, a spiritual map, or an energy device, the pyramid's symbolism reveals a civilization that saw no division between science and spirit, believing that to understand the geometry of the earth was to unlock the secrets of the heavens. While the pyramid's connection to Orion's belt is perhaps its most famous celestial link, The entire Giza Plateau functions as a sophisticated astronomical observatory, meticulously aligned with a pantheon of stars and solar events that were central to the Egyptian soul. The three stars of Orion's belt, representing Osiris, the god of death and resurrection, find their earthly mirror in the three main pyramids, but this is just one piece of a much larger cosmic map. The southern shaft emanating from the Queen's Chamber, for instance, was precisely targeted to align with Sirius, the brightest star in the night sky. To the ancient Egyptians, Sirius was far more than a distant point of light. It was the celestial embodiment of Isis, the goddess of magic and the wife of Osiris. Its first pre-dawn appearance each year, known as its heliacal rising, coincided with the annual flooding of the Nile, the event that brought life-giving silt and water to the fields and guaranteed the kingdom's survival for another year. This alignment transforms the pyramid from a static monument into a dynamic predictor, its internal architecture designed to capture a specific celestial event that signaled the most important moment in the Egyptian agricultural and religious calendar. The solar alignments are equally profound and speak to a deep understanding of the sun's cyclical journey. The Great Pyramid sides are aligned with such precision to the cardinal directions that its shadows cast at the spring and autumn equinoxes would fall perfectly straight, providing a gigantic solar clock that could mark the 2 days of the year when day and night are of equal length. Furthermore, during the summer solstice, the longest day of the year, the setting sun would be seen to sink directly between the two largest pyramids from the perspective of the Sphinx, a dramatic and unmistakable display of celestial choreography. These solar events were not mere astronomical curiosities. They were the bedrock of Egyptian timekeeping, religion, and state power. The precise timing of religious festivals, the beginning and end of the agricultural seasons for planting and harvesting, and even the scheduling of tax collection were all governed by this celestial clock. The pyramid, in its silent, immovable majesty, was the central gear in this vast machine of state and society, a permanent stone guarantee that the cosmic order, or mat, would be maintained. This deep integration of astronomy and architecture reveals a civilization that saw no separation between the earthly and the divine. The sky was not an abstract space but a direct reflection of their spiritual world, and the pyramids served as the permanent anchor points connecting the two realms. By building these colossal structures to mirror the heavens, the Egyptians were effectively bringing the cosmos down to earth, creating a sacred landscape where the rhythms of the universe could be observed, measured, and ultimately influenced. The priest astronomers who designed these alignments possessed a knowledge that was both scientifically advanced and deeply sacred, using the pyramid's passages and angles not just to observe the stars but to commune with the gods they represented. The perfect alignment with Sirius, Orion, and the solstices suggests the pyramid was more than a tomb or a calendar. It was a powerful instrument of ritual, designed to harness the specific energy of these celestial events to facilitate the pharaoh's rebirth and ensure the continued prosperity and stability of the entire nation, forever binding their destiny to the eternal cycles of the sky. Looking up at the apex of the Great Pyramid today, we see a flat, truncated platform, a summit that feels strangely incomplete. It is almost impossible to visualize it as it was originally designed, crowned with a brilliant, gleaming pyramidion, a miniature pyramid made not of common stone, but of electrum, a spectacular natural alloy of gold and silver. This dazzling capstone would have been the final piece placed with immense ceremony, catching the first and last rays of the sun each day, blazing like a second star against the desert sky. Yet, not a single capstone from any of the major Egyptian pyramids has ever been found in situ. Their universal absence is a quiet, persistent mystery. Were these sacred objects stolen, ritually removed, or perhaps never even placed at all? The purpose of the pyramidion extended far beyond mere decoration. It was the culmination of the entire structure's spiritual intent. In Egyptian belief, the Benben stone was a potent symbol of the primeval mound, the first land to emerge from the waters of chaos at the moment of creation. It was upon the Benben that the creator god Atum first stood, bringing order to the universe. By capping their pyramid with this sacred shape, the Egyptians were symbolically completing the process of creation, turning the entire massive structure into a machine for rebirth. The electrum covering was chosen for its incredible reflective properties. It wasn't just shiny, it was literally meant to radiate the power of the sun god Ra, transforming the pyramid into a beacon of celestial energy that would guide the pharaoh's soul directly to the imperishable stars. This wasn't an accessory, it was the spiritual lightning rod for the entire monument. So what happened to them? The most straightforward theory is that they were simply looted. The sheer value of the materials would have made them irresistible targets for thieves across the millennia. A capstone made of solid electrum, even if only a skin over a stone core, would have represented a fortune in precious metal. If they were pried off and melted down, their iconic form would have been lost forever, reduced to anonymous ingots of gold and silver. This is a perfectly logical explanation, yet it feels almost too simple. The pyramids themselves were stripped of their smooth white casing stones, which were repurposed for buildings in Cairo, so the theft of a much smaller, more valuable capstone seems inevitable. But the complete lack of any evidence, no broken mounts, no fragments, no contemporary accounts of their removal leaves room for other intriguing possibilities. Some researchers suggest a more ritualistic form of removal. If the capstone was considered the most charged, sacred part of the pyramid, containing the essence of the pharaoh's connection to the divine, it might have been deliberately taken down and hidden or destroyed upon the conclusion of its function or the fall of a dynasty. This would be similar to the practice of killing a ceremonial object to deactivate its power. Alternatively, there is the fringe but fascinating theory that the capstones were not physical objects at all, but representations of energy or light, a focal point that was never meant to be a permanent physical artifact. This idea, while highly speculative, is fueled by the fact that no capstone has ever been found, not even in the rubble around the pyramid's bases. Perhaps the most compelling alternative theory is that the Great Pyramid was never actually finished. Some evidence points to this. The top courses of masonry are rough and unfinished, unlike the smooth, precision work below, suggesting the final polishing and the placement of the capstone might have been interrupted. If Pharaoh Khufu died before the project's absolute completion, the final, most sacred act of placing the pyramidion might never have occurred. The workforce would have disbanded, and the capstone, potentially stored somewhere nearby, could have been lost to time or looted before it ever reached its destination. The missing apex, then, would not be a mystery of removal, but a permanent state of incompletion, an eternal work in progress that has kept us waiting for its final piece for 4,500 years. The void at the summit remains a powerful symbol of this ultimate unanswered question. But our exploration of Giza's mysteries cannot be confined to what stands above the sand. Some of the most compelling enigmas may lie deep beneath our feet, in a hidden world of tunnels and chambers that has fueled legend for centuries. The idea of a vast subterranean metropolis beneath the pyramids is one of the most enduring and tantalizing myths of ancient Egypt. These are not just modern fantasies, they find their roots in the accounts of revered historical figures. The ancient Greek historian Herodotus, often called the father of history, wrote in the 5th century BC of being told by Egyptian priests about a magnificent labyrinth located near a vast underground lake situated south of the Great Pyramid. He described it as a structure that surpassed even the pyramids, containing 3,000 rooms, 1,500 above ground and an equal number below, a network so complex that without a guide, a visitor would never find their way out. While Herodotus was likely describing a known complex in Hawara, his writings cemented the idea of a hidden underground Egypt in the Western imagination. Perhaps the most famous account comes from the 10th century Arab historian al-Masudi, who wrote that the ancient Egyptians, foreseeing a great cataclysm, built the pyramids as repositories of all their knowledge and science. But he went further, claiming they also constructed vast, vaulted underground passages that were lined with granite and extended for miles, connecting the major monuments and containing artifacts and records of a lost world. He stated that these tunnels were protected by automatic doors and clever mechanical traps to deter intruders, tales that would not be out of place in a modern adventure film. These stories were repeated and embellished by other medieval writers, creating a rich tapestry of lore that spoke of a secret, buried city waiting to be discovered. In the modern era, these legends have been pursued with a mix of serious archaeology and sensational speculation. Perhaps the most famous and controversial explorer was the mysticism-inclined author Dr. Paul Brunton, who in the 1930s claimed to have been initiated into the secrets of the underground chambers by a hidden master. In his book, A Search in Secret Egypt, he describes being led blindfolded into a vast, temple-like hall deep beneath the Giza Plateau, a room he called the Hall of the Gods, filled with ancient artifacts and a profound spiritual atmosphere. While skeptics dismiss Brunton's account as a vivid allegory or an outright fabrication, his story captured the public's imagination and inspired countless others to search for the entrance to this hidden world. The search moved from legend to potential reality with the advent of modern remote sensing technology. Ground-penetrating radar and other seismic tools have begun to map the subsurface of the plateau, revealing a shocking truth: it is not solid rock. In the 1970s, a team from Stanford Research Institute conducted a survey and detected multiple large subsurface cavities and what appeared to be tunnel-like anomalies. More recently, a sweeping survey using advanced GPR and resistivity tomography has revealed a stunning amount of void space. Researchers have identified what looks like a large, rectangular chamber nearly 35 meters beneath the surface behind the western wall of the already known subterranean chamber under the Great Pyramid. They have also mapped a massive anomaly directly beneath the Sphinx, often called the Sphinx Temple, which some interpret as a potential chamber or a network of passages. Most compellingly, a Japanese team from Waseda University, using electromagnetic wave technology, claimed to have identified a massive, sprawling labyrinth of tunnels and rooms extending like a spiderweb directly beneath the three main pyramids. Their scans suggested large, man-made cavities stretching for kilometers, some filled with sand and others potentially holding water, eerily echoing the ancient descriptions of Herodotus. They even pinpointed a specific, deep cavity directly east of the Queen's Chamber, which they suggested could be a significant, undiscovered burial chamber or treasury. So with all this tantalizing evidence, why do these areas remain almost entirely unexplored and unexcavated? The reasons are a complex mix of geology, politics, and preservation. First, the geology of the plateau is treacherous. Digging through the soft, water-saturated limestone is incredibly dangerous, with a high risk of catastrophic collapse that could destroy the very monuments they are trying to investigate. The water table beneath Giza has also risen significantly over the centuries, flooding many of the known subterranean areas like the so-called Osiris Shaft, making them inaccessible without massive and expensive pumping operations. Secondly, and perhaps most significantly, the Egyptian authorities are extremely cautious about granting excavation permits, especially for areas directly beneath the pyramids. The Supreme Council of Antiquities has a paramount duty to preserve the site for future generations, and any invasive digging carries an inherent risk of causing irreversible damage. They rightly prioritize non-invasive methods like GPR, but these can only provide shadowy outlines, not definitive answers. The political and academic landscape is also sensitive. The idea of a lost civilization or vastly older structures, popularized by many of the underground city theorists, directly challenges the established narrative of Egyptian history, creating a natural reluctance to pursue excavations that could potentially upend it. This has created a frustrating stalemate. The radar scans show clear and compelling anomalies, but they are just that, anomalies. They could be natural fissures in the limestone, pockets of sand, or ancient quarrying operations. The only way to know for certain is to dig, but the risks and restrictions make that an almost impossible proposition. So the legends of a hidden underground city persist, suspended in a limbo between tantalizing possibility and unproven myth, a mystery that remains literally buried, waiting for the day when technology or willpower finally allows us to see what truly lies in the darkness below. Yet the profound silence within these chambers may be the greatest illusion of all, for the pyramid is not a silent tomb but a sophisticated instrument of sound, designed to harness vibrations in ways we are only beginning to perceive. Stepping into the king's chamber is an experience that goes beyond the visual. The air itself feels different, thick and humming with a latent energy. This is not imagination but physics. The chamber, constructed entirely from massive, resonant granite blocks, acts as a perfect sound resonator. Experiments have shown that the chamber's dimensions and materials cause it to amplify and sustain specific low frequencies, particularly those in the range of 100 to 200 Hz. When a sound is produced here, it doesn't simply echo. It blooms, filling the space with a rich, omnipresent tone that seems to come from everywhere at once. This is no architectural accident. The precision required to achieve this specific acoustic effect suggests the ancient builders possessed a sophisticated understanding of sound wave behavior and harmonic resonance, knowledge that would not be formally explored in the West for thousands of years. The potential applications of this built-in sound technology are as varied as they are profound. Many researchers believe these acoustic properties were central to the spiritual rituals believed to have taken place within the pyramid. Chanting, drumming, or playing specific instruments like the sistrum within the king's chamber could have generated powerful standing waves, frequencies that would have physically vibrated through the bodies of the participants. This somatic experience could induce altered states of consciousness, a feeling of unity with the divine, or a profound sense of peace and healing. The pyramid, in this view, becomes a massive meditation chamber or a device for spiritual awakening, using vibration to facilitate a shift in human awareness. This idea finds support in ancient Egyptian texts that describe the use of sound in healing and temple rituals, and in modern studies that show specific sound frequencies can reduce stress, alter brainwave patterns, and promote deep relaxation. This leads to one of the most captivating and controversial theories. That sound was not just for ritual, but was the key to the pyramid's very construction. The legend, found in multiple ancient cultures, of stones being levitated into place through the use of chanting, trumpets, or other instruments, has long been dismissed as pure myth. However, a growing number of physicists and engineers are taking a second look. The concept of acoustic levitation is a recognized, though highly advanced, scientific principle. Using precisely tuned sound waves to create a standing wave, scientists can now levitate small objects, even droplets of liquid, in mid-air within a laboratory setting. Theoretically, scaling this principle up would require an immense amount of energy and a perfectly controlled environment, but it is not impossible from a physics standpoint. Could the ancient builders have discovered a way to achieve this on a massive scale? Proponents of this theory suggest that the Grand Gallery, with its extraordinary corbelled and resonant structure, was not a passageway but a giant sound box. They propose that teams of priests or workers, chanting at a specific resonant frequency, could have used the gallery to amplify and focus sound waves, effectively reducing the weight of the multi-ton stone blocks or even allowing them to be guided effortlessly up ramps and into place. This would explain the baffling precision of the stone fitting and the seemingly superhuman task of moving the granite beams in the king's chamber, each weighing over 50 tons. While this remains firmly in the realm of theory, it is a compelling attempt to solve a practical engineering mystery with a technology that leaves no physical trace behind, only its incredible results. The integration of sound into every aspect of ancient Egyptian spirituality underscores a worldview where vibration was seen as the fundamental creative force. The concept of Heka, or divine magic, was often enacted through the spoken word. Certain sounds and names were believed to hold inherent power to affect reality. The pyramid, as the ultimate expression of their architectural genius, can be seen as the physical manifestation of this belief, a permanent, silent note frozen in stone, waiting for the right frequency to bring it back to life and reveal its secrets to those who listen closely enough. Yet the most daunting challenge wasn't moving the stones across the desert, but lifting them onto the pyramid itself. For this, the most widely accepted theory involves a complex system of ramps. The sheer scale of such a ramp system is a marvel of engineering in its own right. A single, straight ramp rising to the peak of the 480-foot structure would have been absurdly massive, requiring more construction material than the pyramid it was meant to build. This has led to more plausible proposals, like a spiraling ramp built against the pyramid's exterior or an internal ramp corkscrewing upward within the structure itself. Some engineers suggest a combination, a long, straight ramp for the lower third of the construction and a more complex internal ramp for the upper, narrower courses. The problem is a frustrating lack of evidence. Despite extensive searching around the Giza Plateau, no remains of a primary ramp structure large enough to service the entire project have ever been conclusively identified. This absence forces us to wonder if the ramps were dismantled for their valuable material, or if we are still missing a crucial piece of the construction puzzle. The logistical coordination required to keep teams of workers hauling blocks up these inclines without creating catastrophic traffic jams is a management mystery that rivals the engineering one, pointing to a level of project planning that feels remarkably modern. This staggering precision extends far beyond the grand architectural alignments and into the very fabric of the pyramid's construction, manifested in the mind-boggling accuracy of its individual stones. To walk among the massive core blocks is to witness a kind of rustic majesty, but when you examine the joints between the finely fitted casing stones or the interior granite blocks, the workmanship shifts into an entirely different dimension. We are looking at stones that were cut and shaped to fit together with gaps often measuring less than half a millimeter, a tolerance that rivals modern machining and seems utterly impossible for a society armed with little more than copper tools and stone hammers. This isn't just stacking rocks, it is a form of three-dimensional puzzle-making on a gargantuan scale, where each multi-ton block was custom-shaped to interlock perfectly with its neighbors, all without a single drop of mortar to hide any mistakes. The evidence for this advanced artistry is scattered across Egypt, providing silent testimony to their methods. At the Giza Plateau itself, and especially at the Osirian in Abydos, we find stunning examples of massive granite blocks carved with complex jigsaw-like patterns. These are not simple square blocks. They are keyed together with butterfly-shaped joints and other intricate cuts that lock them in place, providing seismic stability and ensuring the structure could withstand immense pressure and the passage of millennia. This technique reveals a profound understanding of engineering and physics, showing they weren't just builders but master craftsmen who thought in terms of permanent interlocking strength. So how was this achieved? The prevailing theory, supported by tool marks found on unfinished stones and in quarries, involves a combination of incredible patience and clever abrasive technology. Egyptologists propose that for cutting hard stones like granite and basalt, workers used saws and drills made from copper, a relatively soft metal. The cutting power didn't come from the copper itself, but from a slurry of water and an abrasive material harder than the stone being cut, typically quartz sand. A team of workers would drag a copper saw blade, which was more like a large, toothless strap, back and forth across a granite block, constantly feeding this abrasive slurry into the cut. Each pass of the saw would allow the hard quartz crystals in the sand to score tiny grooves in the granite, slowly grinding through the stone over days or even weeks. The same principle applied to drilling. A tubular drill made of copper would be rotated, probably using a bow drill mechanism with abrasive slurry fed into the hole. The resulting drill cores, some of which have been found, show perfectly uniform grooves spiraling down their length, indicating a consistent feed and rotation rate that would be difficult to achieve by hand without some form of mechanical guidance. However, for many engineers and stonemasons who examine this work today, the abrasive theory, while plausible, presents significant practical challenges when scaled to the level of perfection seen at Giza. The abrasive method is incredibly slow and would have required an unimaginable amount of labor to achieve the flawless, laser-like joints between the casing stones. Critics point out that this technique also tends to produce a slightly curved cut from the saw blade flexing, yet many of the pyramid's joints are perfectly flat across vast surfaces. Furthermore, the precision of the internal angles and the seamless corners on blocks like the granite sarcophagus in the king's chamber suggest a level of control that is hard to reconcile with a simple back and forth sawing motion. This has led to alternative proposals that the Egyptians might have possessed and then lost access to more advanced tooling methods. Some researchers point to the existence of large, circular saw marks on some granite artifacts, suggesting the possible use of massive, mechanically powered saws. Others have explored the controversial idea of using large, fixed saws that were pulled by teams of workers walking in a straight line, which could provide a more consistent, linear cut than a handheld saw. There are even more speculative theories involving the use of vibrational or sonic technology to help fracture the stone along precise lines, or the use of chemical agents that could temporarily soften the surface of the stone, making it easier to work. While evidence for these lost technologies is largely circumstantial, the perfection of the stonework itself remains a powerful argument that our current understanding of their tools may be incomplete. The stone joints of the Great Pyramid stand as a silent, seamless challenge, a testament to a craft that achieved a level of precision that continues to mystify and inspire, forcing us to wonder if the true secret of their construction has indeed been lost to time. What if the ancient builders of the pyramids possessed a secret that made the impossible not just possible but almost simple? What if the answer to how they shaped multi-ton blocks of limestone with such precision wasn't just about brute force or abrasive grit, but a form of ancient chemistry that allowed them to soften even poor stone like concrete? This is the radical proposition at the heart of one of the most contentious and fascinating theories in alternative Egyptology, the idea of chemical hardening, or more specifically, the geopolymer theory. It suggests that the pyramid blocks were not all quarried and hauled, but cast in place using a form of reconstituted stone, a theory that, if proven, would utterly revolutionize our understanding of ancient technology. The primary champion of this idea is the French materials scientist Joseph Davidovits. In the 1970s, Davidovits put forward a startling hypothesis. He proposed that the massive limestone blocks of the Great Pyramid were not cut from natural bedrock, but were instead a form of ancient concrete, a geopolymer, poured into wooden molds directly on the construction site. His theory begins with the raw materials. The Giza Plateau is rich in a specific type of limestone that contains natural clay minerals. Davidovits suggests that workers would have quarried this soft, natural stone not in massive blocks, but by breaking it down into smaller, manageable pieces. This crushed limestone would then be mixed with water and a key ingredient, a sodium carbonate solution derived from the natron salt readily available in Egypt, which was also used in mummification. This alkaline solution, he argues, would have dissolved the silica and alumina within the clay particles in the limestone, creating a sodium silicate gel. This gel acts as a binding agent, turning the entire mixture into a thick, workable slurry that could be transported in buckets up to the pyramid and poured into formwork. As the mixture sets, a natural chemical process called geopolymerization occurs, creating a synthetic stone that is, for all intents and purposes, indistinguishable from natural limestone after a few years of weathering. Davidovits and his supporters point to several compelling pieces of evidence to back this claim. First, they argue that the physics of moving 2.3 million multi-ton blocks, as the conventional theory requires, is simply too overwhelming, whereas moving buckets of slurry would be far more manageable. Second, they highlight the strange texture of the pyramid stones. Under a microscope, samples from the Great Pyramid stones show an amorphous, non-crystalline structure and contain air bubbles, features consistent with cast concrete but highly unusual for sedimentary limestone formed over millions of years under pressure. Furthermore, the stones show a high water content, which is atypical for natural limestone but expected in a poured mixture. Perhaps most visually striking is the way some of the blocks appear to be fused together seamlessly, as if the material between them was once soft and pliable before hardening into a single monolithic piece. Naturally, this theory has been met with fierce opposition from mainstream Egyptology and geology. The criticisms are substantial. Geologists who have examined the pyramid stones argue that they clearly show the fossils, sedimentary layers, and crystalline structure of natural limestone. They contend that the features Davidovits points to can be explained by the specific quarry from which the stone came, the Mokattam Formation, which is known for its variable quality. They also present a powerful logistical counterargument. The amount of fuel and water required to produce the ash and mix the vast quantities of slurry would have been astronomical, potentially a greater logistical challenge than moving the blocks themselves. The city of Cairo, they note, was founded centuries later specifically because of its access to water, a resource that was not abundantly available on the arid Giza plateau during the pyramid's construction. Perhaps the most damaging criticism is the lack of any direct archaeological evidence. No wooden formwork, no mixing pits, no tools for large-scale chemical processing have ever been found at the site. The debate between these two camps remains at a stalemate, a classic clash between a radical, elegant solution and the weight of established evidence. However, the geopolymer theory opens a door to a wider possibility that doesn't require a full acceptance of Davidovits' entire hypothesis. Even if the majority of blocks were quarried, could the Egyptians have used a chemical process on a smaller scale? There are intriguing accounts from other ancient cultures that hint at this knowledge. Spanish chroniclers in the Americas recorded Inca legends about a plant whose juice could soften stone, allowing them to mold the famous perfectly fitting blocks of Cusco and Sacsayhuaman. In Egypt itself, the historian Herodotus was told that the stones for the pyramids were quarried using a mysterious liquid that was poured onto the stone to make it easy to cut. While often dismissed as myth, modern experiments have shown that certain organic acids, like oxalic acid from rhubarb or citric acid from citrus, can indeed etch the surface of limestone, potentially making it softer and easier to shape for a limited time. This wouldn't be about pouring concrete, but about using a chemical agent to temporarily alter the stone's surface hardness, a sophisticated form of material science that would have made the precise fitting of blocks significantly easier. This middle ground suggests that the true secret of the pyramid's construction might not be a single lost technology, but a lost repertoire of techniques, combining immense physical labor with a subtle and now forgotten chemical ingenuity. But the story of the pyramids does not end at the water's edge of the Nile. If we pull back, far back to a global view, an even more staggering pattern emerges. The Great Pyramid of Giza does not stand in isolation. It appears to be one node in a vast, invisible web connecting the most sacred sites of the ancient world. This is the mystery of global alignment, where the footprints of separated cultures seem to lock together in a silent, geometric dance across continents and millennia. Consider the precise placement of these monuments. The Great Pyramid sits at the coordinates 30 degrees north latitude. Now, trace that same line of latitude around the globe. As you travel east, you encounter the ancient cities of Persepolis in Iran and the lost city of Mohenjo-Daro in the Indus Valley. Continue further and you cross over the sacred temples of Lhasa in Tibet. While the alignments are not always mathematically perfect to the second, their proximity is far too consistent to be dismissed as mere chance. It suggests that the builders, whoever they were, possessed a sophisticated understanding of the Earth's spherical nature and were capable of calculating their position on it with remarkable accuracy, a feat of geodesy that historically belongs to a much later age. This connection becomes even more profound when we move from simple latitude to complex geometry. The concept of ley lines, hypothetical alignments of ancient sites, has long been a staple of alternative history. While often criticized, certain geometric relationships are undeniably compelling. For instance, the azimuth, or the angle from true north, of the Great Pyramid's southern face, if extended as a great circle line across the planet, comes within mere meters of intersecting with the ancient Nazca lines in Peru, those massive geoglyphs whose purpose remains one of archaeology's greatest puzzles. Another proposed great circle connects Giza to the sacred Anglo-Saxon site of Stonehenge in England, and then onward to the ancient and mysterious ruined city of Angkor Wat in Cambodia. Each of these sites is a pinnacle of its own cultural achievement, separated by oceans and thousands of years, yet potentially bound by a single, invisible line of intent. Perhaps the most striking alignment is not with lines, but with constellations mirrored on the ground. We've already explored how the three pyramids of Giza mirror the stars of Orion's belt. But this celestial blueprint seems to be a global language. The layout of the key pyramids at Teotihuacan in Mexico, the Pyramid of the Sun, the Pyramid of the Moon, and the Temple of the Feathered Serpent also reflects the pattern of Orion's belt, just as the Egyptian pyramids do. This is not a vague resemblance. The relative sizes and positions of the structures correspond to the brightness and arrangement of the three stars. Two completely independent cultures on opposite sides of the Atlantic, with no known contact, both chose to build their most important ceremonial centers as a terrestrial map of the same constellation. The odds of this happening by accident are astronomically low. This global patterning forces a monumental question upon us. Are we looking at evidence of a coordinated ancient global civilization, a network of knowledge that predates our current historical model? The diffusionist theory argues yes, proposing that a seafaring, advanced culture traveled the world in the distant past, seeding these architectural and astronomical ideas everywhere they went. This progenitor civilization, perhaps remembered in myth as Atlantis or another lost world, would have served as a common source explaining the shared mathematical principles, the astronomical alignments, and the recurring mythological themes found from Egypt to the Americas. The alternative explanation favored by mainstream academia is independent invention or psychic unity. This concept posits that humanity, faced with similar spiritual questions and practical challenges, independently arrived at similar solutions. The pyramid shape is inherently stable, an obvious choice for building tall structures that will last. The stars of Orion are among the most prominent in the winter sky, a natural focal point for cultures developing astronomy. In this view, the alignments are a testament to the universal human mind and its shared response to the cosmos, not proof of physical contact. Yet, the precision of the geometric and astronomical correlations makes the argument for complete isolation increasingly difficult to sustain. It suggests the possibility of a middle path, not a single global civilization, but a much older, shared pool of knowledge that different cultures accessed and interpreted in their own ways. This could have been a legacy from a time before the sea levels rose at the end of the last ice age, when land bridges connected continents and ideas could flow more freely between cultures we now consider separate. The pyramids and the other ancient marvels aligned with them, would then be not the beginnings of civilization, but the magnificent, enduring remnants of its first golden age, a silent chorus of stone pointing toward a forgotten chapter in the human story. Yet deep within the pyramid's stone heart, two of its most captivating features are almost impossibly small. The narrow shafts, no larger than a dinner plate, that extend from the king's and queen's chambers into the thick masonry. For over a century after the pyramid's exploration, the prevailing theory was a practical one. These were simple ventilation shafts, designed to allow the workers to breathe during construction or to provide airflow to the chambers afterward. But this explanation always felt insufficient, almost mundane for a structure of such profound spiritual intent. A practical ventilation system would not require such precise, angled construction through hundreds of feet of solid stone, nor would it explain why the shafts from the Queen's chamber were originally sealed at both ends, discovered only when a British engineer named Wayman Dixon theorized their existence and broke through the wall to find them in 1872. The true purpose of these enigmatic tunnels began to reveal itself not through archaeology but through astronomy. In the 1960s, Egyptologist Alexander Badoy, working with the renowned astronomer Virginia Trimble, made a staggering discovery. They calculated that the southern shaft of the king's chamber was precisely aligned around 2500 BC with the belt of the constellation Orion, which the ancient Egyptians associated with Osiris, the god of the afterlife and rebirth. Simultaneously, the northern shaft from the same chamber pointed directly at Alpha Draconis, which was the pole star at that remote time, a star the Egyptians saw as an eternal, fixed point in the northern sky, an imperishable realm for the soul. This was no coincidence. It was a deliberate, celestial targeting system built into the very fabric of the pyramid. The shafts from the Queen's chamber revealed an equally profound alignment. Its southern shaft was aimed at the star Sirius, the brightest in the night sky, which was sacred to the goddess Isis, the wife of Osiris and a divine magician. The heliacal rising of Sirius, its first appearance just before dawn after a period of invisibility, coincided with the annual flooding of the Nile, the event that brought life to the kingdom. The northern shaft of the Queen's chamber targeted the star Kochab in the constellation Ursa Minor, another circumpolar star associated with eternity. These alignments transformed the shafts from simple air channels into something far more magnificent, spiritual conduits or pathways for the soul. This leads to a beautiful and widely accepted theory about the pyramid's final funerary ritual. Imagine the final ceremony for the entombed pharaoh. The granite plugs sealing the ascending passage would have been slid into place, and the workman's exit through the descending corridor would have been sealed shut. The priests would then have exited through a small, secret escape shaft, later sealed from the outside. At the moment of this final closure, the king's chamber would have been utterly sealed and pitch black. But then, during specific nights of the year, a shaft of starlight from the precisely aligned tunnels would have pierced the absolute darkness, its faint light illuminating the sarcophagus. This celestial spotlight would have served as a divine guide, a literal ray from the imperishable stars, intended to direct the soul of the deceased king directly from his physical body into the heavens to take his place among the eternal gods. But the function may have been even more complex than a one-way exit. Some researchers propose a dual purpose for these channels, suggesting they were not just exit routes but also potential entryways for divine energy. The ancient Egyptian concept of the soul was multifaceted, involving different aspects like the Ka life force and the Ba personality. It's possible the pyramid's design facilitated a continuous cycle, allowing the Ba to travel out to the stars while also drawing the celestial energy of the gods down into the tomb to sustain the Ka within the mummified body for eternity. The shafts, therefore, would have acted as a permanent cosmic umbilical cord, connecting the mortal remains of the king with the infinite power of the universe, ensuring his resurrection and eternal life not as a one-time event, but as an ongoing state of divine existence. These four narrow tunnels, often overlooked because of their size, ultimately reveal the pyramid's grandest ambition: to serve as a machine for immortality, an engine of stone and starlight designed to conquer death itself. This profound silence leads us directly into another enduring puzzle: the baffling lack of internal inscriptions and contemporary records. In a culture renowned for covering every temple wall and tomb chamber with detailed hieroglyphs that narrated the lives of gods and pharaohs, the stark, blank walls of the Great Pyramid's main chambers feel like a deliberate void. Unlike the later pyramids of the 5th and 6th dynasties, whose inner walls are covered in the beautiful and intricate pyramid texts, spells, and incantations to guide the pharaoh's soul, the chambers of the Great Pyramid are almost completely devoid of any hieroglyphic writing. This absence is deafening. If this was the ultimate tomb for the greatest pharaoh of the 4th dynasty, why is it not adorned with the sacred texts meant to ensure his safe passage to the afterlife? The few inscriptions that do exist are problematic and have fueled debate for over a century. The most famous are the quarry marks and workgang names found in the sealed relieving chambers above the king's chamber, which include a cartouche bearing the name of Khufu. For mainstream Egyptology, this is the definitive proof that settles the debate. The pyramid was built for Khufu. However, critics point out the strange context. These marks were crudely painted in red ochre in spaces that were never meant to be seen again, sealed off forever upon the pyramid's completion. They are administrative graffiti, not a formal, dedicatory inscription. Some have even questioned their authenticity, suggesting they could have been added by a restoration crew during Khufu's reign rather than the original builders. The complete lack of any other formal inscription within the pyramid itself remains a powerful anomaly that the standard tomb theory struggles to explain. This void of internal documentation is matched by an equally puzzling gap in the external historical record. One would expect a project of such unimaginable scale, consuming the resources of the entire kingdom for decades, to be meticulously recorded and celebrated in contemporary texts and reliefs. Yet, no such detailed records have been found. There are no papyrus scrolls outlining the architectural plans, no lists of materials, no diagrams of ramp systems, and no wall carvings depicting the actual construction process in detail. The closest we have is the famous scene from the tomb of Jehu'tihotep, which shows a massive statue being moved on a sledge, but this dates from a much later period. The absence is so complete that it feels intentional, as if the knowledge of how to build these structures was considered so sacred or so powerful that it was deliberately kept secret, shared only among a privileged priestly class and never committed to common record. This pervasive silence has become fertile ground for alternative theories. If the pyramid was not primarily a tomb, but something else, an energy generator, an astronomical observatory, or an initiation hall, then the lack of funerary texts makes perfect sense. Its function would have been its own message, encoded not in words but in mathematics and alignment, understandable only to those initiated into its mysteries. Furthermore, if the structure is far older than the 4th dynasty, as some geological and astronomical evidence suggests, then the lack of contemporary Egyptian records is easily explained. They simply didn't exist because the pyramid was already ancient when Khufu came to power. In this scenario, the later Egyptians might have inherited these magnificent structures from a lost predecessor civilization, and in their awe, they adopted them into their own culture, claiming them as tombs for their own pharaohs without fully understanding their original purpose. The missing records force us to confront our uncomfortable possibility about the fragility of knowledge itself. We live in an age of ubiquitous information where every detail is documented and stored. We assume that an advanced society would naturally leave a clear record of its achievements, but the pyramids stand as a stark reminder that knowledge can be lost. Entire libraries, like the Library of Alexandria, can burn. Oral traditions can be broken by war, famine, or cultural collapse. Priestly castes can vanish, taking their secrets with them to the grave. The true story of the pyramids may not have been written down because it was never meant to be. It was a secret science passed from master to apprentice, and when that chain was finally broken, the greatest architectural wonder of the world was left standing in mute silence, its builder's intentions hidden forever behind a veil of stone and time. Yet as we consider the silent void of official records, we must also confront a legend that has roared through popular culture for over a century, a tale not of quiet absence but of dramatic, supernatural retribution. The Curse of the Pharaohs is perhaps the most famous and enduring myth to emerge from Egypt's sands, a story that has captivated the world's imagination and forever linked archaeology with a sense of thrilling danger. The legend crystallized in the public mind with the discovery of Tutankhamun's tomb in 1922, an event that should have been a pure triumph for its financier, Lord Carnarvon, and its excavator, Howard Carter. Instead, the untimely death of Lord Carnarvon just a few months after the tomb's opening provided the spark that ignited a global media firestorm. Carnarvon died in Cairo from an infected mosquito bite, which swiftly led to pneumonia and blood poisoning. The press, hungry for a sensational story, was quick to pounce. They reported that at the exact moment of his death, all the lights in Cairo mysteriously failed, and back in England, his beloved dog Susie was said to have let out a howl and dropped dead. The myth was born, a curse inscribed somewhere that promised, "Death shall come on swift wings to him who disturbs the peace of the king." This narrative took on a life of its own, fueled by a series of subsequent deaths of others connected to the excavation. While Howard Carter, the man who actually first breached the tomb and spent years inside it, lived until the age of 64, the passing of others, like American financier George J. Goode, who died of pneumonia after visiting the tomb, and Carnarvon's half-brother, who died of blood poisoning months later, were eagerly added to the curse's tally. The public, already enthralled by the glamour and mystery of Egyptology, was more than willing to believe in a supernatural vengeance protecting the ancient rulers. The curse became a staple of Hollywood films, pulp novels, and newspaper headlines, creating a powerful, albeit fictional, aura of peril around archaeological discovery that persists to this day. But if we strip away the sensationalism, what are we left with? The first and most crucial fact is that no such curse was ever found inscribed in Tutankhamun's tomb. The famous "swift wings" quote was entirely fabricated by a journalist. The actual protective spells found in other Egyptian tombs are far less dramatic. They are warnings meant to deter tomb robbers by threatening their afterlife with phrases like, "They will not be given a burial," or "Their bodies will perish." They were spiritual deterrents, not promises of immediate physical death. Furthermore, if a curse were truly effective, its primary target should have been Howard Carter, who not only discovered the tomb but personally spent a decade cataloging its contents. Instead, he lived for another 17 years after the opening. A statistical analysis of the team members who entered the tomb reveals that the average age at death was over 70 years, hardly evidence of a supernatural killer on the loose. So if the curse wasn't supernatural, what explains the cluster of illnesses and deaths? Science offers several compelling theories that are far more frightening in their own way. The first and most plausible explanation involves biology. A sealed tomb, especially one that had been closed for over 3,000 years, is a perfect breeding ground for potentially deadly microorganisms. Researchers have suggested that ancient, dormant molds and bacteria could have been stirred up when the tomb was unsealed. In particular, the species Aspergillus niger and Aspergillus flavus, toxic molds that can cause severe allergic reactions, hemorrhaging, and even death in those with compromised immune systems, have been found in other sealed tombs. Lord Carnarvon was in poor health long before he ever went to Egypt. He was severely injured in a car accident years earlier and was described as sickly and frail. His system would have been uniquely vulnerable to a massive pulmonary infection from these ancient spores, making his death a tragic coincidence of timing and biology, not a supernatural curse. Another fascinating scientific theory points to radiation. Some physicists and researchers have proposed that the ancient Egyptians might have been aware of certain radioactive materials, like uranium or radon, and could have intentionally incorporated them into the tombs as a physical defense mechanism. Granite, which was used liberally in burial chambers and sarcophagi, naturally contains trace amounts of uranium and emits radon gas, a known carcinogen that can accumulate to dangerous levels in unventilated spaces. Prolonged exposure inside a sealed tomb could have led to radiation sickness, which can cause cancers, aplastic anemia, and infections due to a weakened immune system, symptoms that could easily be mistaken for a mysterious plague. While this remains a more speculative idea, it presents a chilling possibility that the tombs were booby-trapped not with swinging blades and rolling boulders, but with an invisible, lethal physics that we are only now beginning to understand. The impact of the curse legend on archaeology itself has been a double-edged sword. On one hand, it generated an unprecedented wave of public interest and funding for Egyptology, making global celebrities out of archaeologists and ensuring that museums would be filled with eager visitors for generations. On the other hand, it fostered a disrespectful and sensationalist attitude toward the sacred spaces of another culture, framing them as settings for horror stories rather than places of profound spiritual significance. The curse narrative also provided a convenient scapegoat for tragedies that were simply the result of the perilous conditions of early 20th century exploration, where modern medicine was still in its infancy and the long-term consequences of exposure to unknown elements were not understood. Ultimately, the curse of the pharaohs tells us less about ancient Egypt and more about ourselves, our love for a good story, our tendency to seek patterns and meaning in random tragedy, and our fascination with the line between science and the supernatural. It is a powerful testament to the enduring mystique of the pharaohs, a mystique so potent that even a century later, we are still unraveling the very real scientific secrets they may have left behind, secrets far more complex and ingenious than any simple curse. But to fully grasp the challenge to history posed by the Sphinx, we must move from the stars and look down directly at the stone from which it was carved. The traditional Egyptological narrative places the creation of the Sphinx during the reign of Pharaoh Khafre, around 2500 BC, making it roughly contemporary with the Second Pyramid at Giza. This attribution is based on stylistic analysis and its proximity to Khafre's Valley Temple. For over a century, this was the accepted truth, an unquestioned pillar of the historical timeline. That is, until a geologist looked at the monument not as an art historian, but as a scientist reading the story written in stone. In the early 1990s, Dr. Robert Schoch, a professor of geology at Boston University, brought his expertise to the Giza Plateau. He was initially skeptical of any alternative theories, but what he observed on the body of the Sphinx and the walls of its enclosure trench stopped him in his tracks. The erosion patterns were all wrong. The classic model of wind and sand erosion, which would certainly be the dominant force in the Sahara Desert for the last 5,000 years, creates horizontal weathering, smoothing and scouring surfaces in a relatively even fashion. But the erosion on the Sphinx and its enclosure walls is dramatically different. It is characterized by deep, vertical, and undulating fissures, with a distinctive rolling and waves-like profile. To a geologist, this is the textbook signature of water erosion, specifically from prolonged and heavy precipitation. This observation led to a startling conclusion. The last period in which the climate of Egypt was sufficiently wet to produce this kind of rainfall runoff was during the late Pleistocene and early Holocene epochs, which ended around 9,000 years ago. After this, the Sahara Desert began to form, and the hyper-arid conditions we see today took hold. For the Sphinx to exhibit such deep water erosion, Schoch argued, its core body must have been carved not in 2500 BC, but at a minimum of 7,000 to 9,000 years ago and potentially even earlier. This would place its origins not in the dynastic period of the pharaohs, but in a prehistoric era, a time when humanity was supposedly comprised of simple hunter-gatherers, incapable of such monumental architecture. Unsurprisingly, this hypothesis was met with immediate and fierce resistance from the Egyptological establishment. Their counterarguments were multifaceted. Some suggested that the erosion could be explained by the capillary action of moisture rising from the nearby Nile or from dew condensation. Others pointed to the effects of wind, which can indeed cause weathering in limestone, especially when it carries abrasive sand particles. However, geologists like Scott counter that wind and sand create a very specific type of erosion, often leaving behind horizontal ledges and sharp edges, not the deep, soft, flowing curves seen in the Sphinx enclosure. They also note that the enclosure walls show this water weathering to a much greater degree than the Sphinx itself, which would be expected if the statue, being a freestanding object, was subject to wind from all directions that could partially clean and reshape it, while the walls were sheltered and allowed water to pool and run down their faces. The debate quickly became a classic clash of disciplines. Egyptologists defended their timeline based on archaeology, pottery styles, and the cultural context they had painstakingly built. Geologists argued that the stone itself does not lie. The physical evidence of water must be accounted for. This wasn't merely an academic squabble. It was a fundamental disagreement over the very methods we use to understand the past. Should cultural context override physical science, or should the evidence carved into the bedrock force us to reconsider our cultural assumptions? If Scott and other like-minded geologists are correct, the implications are nothing short of revolutionary. A sphinx dating back to 9,000 BC or earlier would shatter the conventional narrative of human civilization. It would mean that a sophisticated, organized society with advanced stone-working capabilities existed thousands of years before the rise of Sumer and ancient Egypt, the cultures traditionally credited as the cradle of civilization. This society would have possessed the engineering knowledge to plan, quarry, and sculpt a colossus, and potentially the astronomical knowledge that is encoded across the Giza Plateau. Their civilization, for reasons unknown, must have collapsed or transformed, leaving behind only their most durable monuments, which the later Egyptians then discovered, adopted, and perhaps restored. This theory offers an elegant, though speculative, solution to many of the pyramid's own mysteries. The staggering mathematical and astronomical precision, the advanced stone-working techniques, and the lack of internal funerary inscriptions could all be explained if the Giza complex was originally the work of a much older, lost civilization. The pharaohs of the Fourth Dynasty would not have been the original architects, but the inheritors and restorers of a pre-existing sacred site, which they then incorporated into their own culture, adding their own mark with the nearby pyramids. The water erosion on the Sphinx is not just a geological curiosity. It is a potential crack in the foundation of history itself, a silent, stone-hewn testament to the possibility that the story of human achievement is far older and far more mysterious than we have ever been taught. This staggering integration of celestial alignments and precise mathematics brings us to perhaps the most debated and astonishing set of correlations: the apparent encoding of fundamental mathematical constants within the pyramid's very dimensions. We've already seen how the structure's form incorporates pi through the ratio of its perimeter to its original height, but the numerical mysteries deepen far beyond a single ratio. The Great Pyramid seems to whisper secrets of higher mathematics that appear, at first glance, to be impossibly anachronistic. One of the most discussed and controversial encodings is that of the golden ratio, often denoted by the Greek letter phi, approximately 1.618. This irrational number, celebrated for its role in aesthetic beauty and harmonic proportion throughout nature, from the spiral of a nautilus shell to the branching of trees, seems to be present in the pyramid's geometry. The ratio of the pyramid's apothem, the length from the center of the base to the apex, to half the length of its base is remarkably close to phi. Furthermore, if you take the surface area of each of the 4 triangular faces and divide it by the area of the base square, the result again approaches this golden proportion. These consistent appearances suggest to many that the architects intentionally designed the pyramid to embody this divine ratio, embedding a fundamental law of the natural world into their most ambitious project. Even more mind-bending is a correlation that emerged with modern measurements, a potential link to the speed of light. The pyramid's latitude is 30 degrees north. If you take the latitude and multiply it by the pyramid's original height in meters, you get a number that is 99.9% accurate to the speed of light expressed in meters per second. This particular correlation is often met with the most skepticism, and for good reason. The meter itself is a modern unit of measurement defined in 1793 based on the circumference of the Earth. To suggest the ancient Egyptians used the meter is a significant chronological problem. However, proponents of a deeper, lost knowledge argue that the meter might not be an arbitrary invention but a rediscovery of a natural, geodetic constant known to a much older civilization. They posit that the pyramid's builders understood the dimensions of the Earth with incredible precision and used a unit of length that was inherently tied to those planetary measurements, a unit that we would later independently arrive at and call the meter. In this view, the alignment with the speed of light isn't a coincidence of our modern units, but a stunning byproduct of the pyramid's design being based on the true proportions of the planet itself. The debate surrounding these encodings is one of the most polarized in all of alternative history. On one side, mainstream Egyptologists and mathematicians largely dismiss these findings as a classic case of number juggling or apophenia, the human tendency to find meaningful patterns in random data. They argue that with a structure as mathematically rich as the Great Pyramid, if you take enough measurements and perform enough arbitrary calculations, you can inevitably find correlations to almost any significant number you seek. They point out that the ancient Egyptians, in all their surviving mathematical papyri, never demonstrated any theoretical understanding of irrational numbers like pi or phi. Their mathematics was practical and additive, designed for accounting and construction, not for abstract philosophical geometry. The correlation to the speed of light, they contend, is particularly fanciful, requiring the use of a modern unit of measurement and a specific mathematical operation that has no basis in any known Egyptian mathematical practice. From this perspective, these encodings are not evidence of ancient genius, but a testament to modern pattern-seeking imagination. Yet, the counterargument from those who see intentional design is profoundly compelling. They ask us to consider the sheer volume and consistency of the correlations. Finding one or two mathematical constants could be dismissed as coincidence, but the pyramid presents a whole suite of them: pi, phi, the number of days in a year, and potentially the speed of light, all integrated into a single, cohesive structure. This, they argue, points toward a blueprint of incredible depth and intention. They propose that this advanced mathematical knowledge was likely the guarded secret of a small, elite priestly class, an oral tradition of sacred geometry that was never written down in the common administrative texts that have survived the ages. The pyramid, in this view, was not merely a tomb but a stone library, a permanent repository of this advanced geodetic and astronomical knowledge, encoded in its proportions for future generations, or perhaps for the gods themselves. It stands as a permanent, silent challenge to our linear view of human progress, forcing us to wonder if a golden age of scientific understanding rose and fell long before recorded history began, leaving only these immense cryptic monuments as its sole enduring testament. When we step back and view these 25 mysteries not as isolated puzzles but as interconnected pieces of a single grand enigma, a startling overarching theory begins to take shape. It is the compelling idea that the true secret of the pyramids lies in a suite of advanced technologies that were once possessed by their builders but have since vanished from human knowledge. This is not merely a story of forgotten techniques but a radical challenge to our entire understanding of history, suggesting that human progress is not a straight upward line but a circle, or perhaps a series of peaks and valleys with entire epochs of achievement lost to time. So what might these lost technologies have been? Based on the evidence, we can speculate about several profound possibilities. The first is a sophisticated science of materials far beyond simple copper chisels and stone hammers. This could have included chemical or organic compounds capable of softening stone, making it pliable enough to be molded, poured, or shaped with incredible precision. Imagine a liquid agent derived from plants or minerals that could temporarily alter the molecular structure of limestone or granite, allowing artisans to achieve those seamless, machined-like joints. This would explain the bizarre tool marks that look more like scooping than chiseling, and the strange air bubbles found in some pyramid stones that are atypical of natural limestone. Another lost technology could have been an advanced understanding of energy and vibration. The precise acoustic properties of the king's chamber, designed to amplify specific resonant frequencies, point to a science of sound that we are only now beginning to rediscover. This knowledge might have been applied practically in the construction process itself, using tuned vibrations to reduce the weight of massive blocks or even to levitate them into place. The ancient legends of stones being moved by the sound of trumpets or chanting, long dismissed as myth, could be a faded cultural memory of a real and sophisticated sonic technology that manipulated matter in ways that appear magical to us. A third category involves a lost geodesic and astronomical science. The pyramid's perfect alignment to true north, its encoding of pi and phi, and its potential reflection of the Earth's dimensions suggest its builders possessed a spherical understanding of our planet and its place in the cosmos that rivaled the knowledge of the Enlightenment era. They may have used tools and instruments for celestial navigation and land surveying of such refinement that they have left no archaeological trace, perhaps because they were made of perishable materials or were considered so sacred they were never buried with their owners. The question of why such transformative technologies disappeared is as haunting as the technologies themselves. The most likely explanation is a catastrophic collapse of the civilization that nurtured them. A sudden and severe climate shift, like the desertification of the Sahara, a massive planetary cataclysm, or a prolonged dark age following a war or resource depletion, could have shattered the complex social structure necessary to maintain this advanced knowledge. When societies fracture, the specialized priestly or artisan classes who are the sole guardians of such secrets can vanish within a generation. The knowledge, passed down through strict oral traditions and apprenticeships, dies with them, leaving behind only the immense, indestructible monuments as silent witnesses to their genius. The technology to build the pyramids may not have been gradually improved upon. It may have been a peak from which humanity fell, and we have been climbing back toward it ever since. This theory of lost technology directly confronts and dismantles the linear view of human progress, the comforting idea that we started primitive and have been getting steadily smarter and more advanced ever since. The pyramids stand as a monumental counterargument, suggesting that intellectual and technological development can be cyclical. A culture can reach a breathtaking zenith of understanding, only to have that knowledge wiped away by time and disaster, forcing subsequent civilizations to start over from a much more basic point. We are not necessarily the pinnacle of human achievement. We may be the heirs to a legacy we don't even fully remember, rediscovering fragments of a science that was once whole. The silent, perfect stones of the Great Pyramid are not a question mark from our primitive past. They are a question mark placed squarely in the path of our assumed future, asking us to reconsider everything we think we know about the journey of humanity. From the impossible precision of its alignment to true north, to the staggering logistics of moving 2.3 million stones, and from the hidden chambers detected by cosmic rays to the eerie absence of its original capstone, these 25 mysteries form a constellation of questions with no easy answers. We've grappled with the enigma of their construction, debating ramps and lost sonic technologies. We've pondered their purpose, questioning if they were tombs, power plants, or celestial gateways. We've followed the astronomical alignments to Orion and Sirius, and we've stared into the deep, water-worn fissures of the Sphinx, confronting a timeline that threatens to rewrite history itself. Each mystery on its own is a fascinating puzzle, but taken together they form something far greater, a monumental testament to the limits of our current understanding. This is the true power of the pyramids. They are not simply relics of a bygone age, they are a permanent question mark carved into the landscape of human achievement. They defy our tidy categorizations and challenge the very narrative of linear progress. They stand as a humbling reminder that a civilization we often label as ancient or primitive may have possessed insights and capabilities that we are only just beginning to glimpse, let alone comprehend. They force us to admit that history is not a closed book but a story with missing chapters, and that some of the most profound secrets are still buried, waiting for the right key to unlock them. And that is precisely why they continue to captivate us generation after generation. It's not just about finding a single answer, it's about the thrill of the search itself. The pyramids invite us to wonder, to speculate, and to dream. They connect us to the awe that the first archaeologists must have felt, and to the infinite curiosity that drives us to look up at the stars and deep into our own past. They are a catalyst for imagination, inspiring engineers, astronomers, artists, and dreamers to look at the problems of the ancient world with fresh eyes and modern tools. So as we conclude this journey through 25 of their greatest secrets, remember that the conversation is far from over. What resonates most deeply with you? Do you find the geological evidence for a much older Sphinx compelling? Are you convinced by the theories of advanced sonic technology or ancient geopolymer concrete? Or does the traditional archaeological narrative, with its armies of workers and incredible human ingenuity, still hold the most weight for you? The search for truth is a collaborative effort, and every new perspective brings us closer to understanding. We want to hear your voice in this ongoing exploration. Share your own theories, your questions, or even your personal experiences if you've ever stood before these giants yourself in the comments below. Let's keep the mystery alive and continue questioning.